Hi guys, so today we'll be solving this problem called maximum performance of a team. Let's read it. You are given two integers n and k and two integer array speed and efficiency, both of length n. There are n engineers numbered from 1 to n. Speed of I and efficiency of I represent the speed and efficiency of the ith engineer, respectively. Choose at most k different engineers out of the n engineers to form a team with maximum performance. The performance of a team is the sum of their engineers' speeds multiplied by the minimum efficiencies among their engineers. Return the maximum performance of this team. Since the answer can be a huge number, return it modulo 10 raised to 9 plus 7. Okay, so what we have been given is one is a speed array, another is an efficiency array, and we've been given a size of the team that we need to form. Now the size of the team should have the maximum performance. We have been given the maximum performance formula, which is the speed should be maximum into multiplied by the minimum efficiency among all of the engineers that we have. Okay, so for example, we have a team of two, which is k is equal to 2. So we have speed is equal to, we select the first uh, engineer with the maximum speed, which is 10, and we see its efficiency is 4. And then we select the next engineer with speed 5 and efficiency as 7. And then when we calculate the performance, it is 10 plus 5 into minimum of mm, the efficiency between the first and the second engineer. So minimum of 4 and 7 is 4, and 15 into 4 would give us 60. So that's what we need to do. And yes, so how we can solve this problem is that uh, you know we can find every uh, combination of engineers forming a team, and we'll be making the team according to taking in place that every engineer that we encounter has the minimum efficiency. Okay, when we say that that is a minimum efficiency, and we go through the whole the whole set of engineers that we have, and we check which is the one with maximum speed and minimum efficiency. We take that and form a team. And you know similarly, here we can see that we have certain integers which have for example, 8 has efficiency 2, but it is better to have 5 multiplied, 5 as a speed, and the minimum efficiency between them, if we take 10, should be 4. So that is better than the minimum, than having minimum efficiency as 2 if we took 8. Okay, so we need to make that choice, and I'll be explaining how to do that. So first of all, what we'll be doing is that we'll be maintaining a vector or pair int called engineers. So I'll be keeping all of the engineers along in one place so that we can access their speed and efficiency all along it. So I0 is less than n, I plus plus, and engineers dot emplace underscore back speed of, we'll be first maintaining efficiency because we need to sort it according to the efficiency, and because we need the minimum, right? So I'll be sorting it according to the efficiency of I and speed. Now we need to sort it. So our uh, engineers dot r begin, we are passing a reverse iterator because we need to sort it according to according from increasing to decreasing. Okay, so we need to do that for, so basically a decreasing order we need to follow, and we'll be passing the end pointer here, which is the reverse end. So this will give us the the set of engineers with decreasing order of efficiency. Now we'll be maintaining speed, okay, uh, sample speed, let's call it sample speed of that particular integer in engineer, and Then I'll be also maintaining answer. Okay. And then I'll be also taking a priority queue because we need to keep the set of engineers which have the maximum speed together. So for that, we'll be maintaining a priority queue. So priority queue and greater int, which will be min heap, because we need to take out all of the engineers with the minimum speed. So we'll be checking if the we'll be taking the set of engineers together, and whichever is the minimum engineer minimum speed that an engineer has, so we'll be taking out of the set that engineer which has the minimum speed. So for that int, we'll call it pq. Okay. And it's similar like removing the kth largest element from an array. So it's similar like that. Then we'll be running through engineers. So auto performance, let's call it, in engineer. Now in engineers, what we'll be doing is that every engineer that we have, we put it to sample speed plus performance dot second. Okay. So we'll be adding all the speed of every engineer, and we'll be pushing it into the queue. Push performance dot second. Okay. Now we'll be checking if pq dot size is greater than k. Okay. If it's greater than k, at that time we'll be taking out that element, and we'll be popping it out. And before that, we'll be also decreasing the sample speed because we are taking that engineer out, right? So decreasing the sample speed. And then after this, we'll be um, checking that whatever is the maximum performance between answer and basically the sample speed. And one more assumption that we'll be doing is that every engineer that we encounter has the minimum efficiency. Okay. We'll be considering that. So according to that, we'll be finding all the engineers efficiency in that particular set that we have. We'll be considering all of the minimum efficiency that we have for every engineer, and whichever is the maximum performance that we get, we'll be storing it in the answer. So sample speed into pq dot first, which is the speed, which is the efficiency. Okay. And then simply we'll come out of the loop, and since we need to return it in modulo, right, it's 1e9 plus 7. So I'll be returning answer and percent, which is modulus int of 1e9 plus 7. Okay. This should work. What we have done, reiterating through again. So we've maintained a vector where we are placing the efficiency and speed together. Now we are sorting it by decreasing order, and we've maintained a priority queue for storing the minimum, for storing the speed together for particular case set of engineers, and removing the minimum speed. And then we are iterating through the engineers, and we are checking which is the we are adding every engineer speed to sample speed, and we are pushing it into the queue also, so priority queue. And then we are checking if the priority queue size is greater than k, which is the set of engineer that we need to have, the team that we need to create. So if the engineers are more than k, then we remove from the sample speed, which is the minimum speed engineer. Okay. Because we are having a min heap, so minimum speed engineer would be removed from here. And then we'll be checking which is the maximum performance that I can get from a set of engineers, and we'll be considering that every current engineer has the minimum efficiency. So that is done here, and then we'll be returning it modulo 7. Let's run the code to See if everything okay. PQ, no, performance. Okay, yes, and that is accepted. So I hope you guys understood the problem. Do solve it, and do like this video, subscribe to my channel, and yes, thank you.